Hello friends. Now let's look in detail what a bi-connected component is. As a per the definition, graph is called bi-connected if it doesn't have any articulation point. What is articulation point? It's a node in the graph that if it is removed from the graph, then the graph will break into multiple pieces. So such a node which breaks a graph into multiple graphs after its deletion is called an articulation point. Okay, let's take this example and try to understand whether any of the nodes is articulation point or not. Okay, so we have one graph here having 10 nodes 1 2 3 4 5 6 7 8 9 and 10, and if you look at it, so all of them are connected to others somehow, maybe directly or maybe through other nodes, but yes, there is connection. Say 1 to 2 there is connection, 1 to 2 1 to 3 via 2 it is connection, 1 to 4 it is directly connected, 1 to 5 if you see then via 2 it is connected, 1 to 6 means 1 to 2 2 to 5 5 to 6 there is connection, 1 to 7 means 1 to 2 2 to 7 there is connection, 1 to 8 means 1 to 2 2 to 8 and so on. 1 to 9 means 1 to 2 2 to 3 3 to 9, 1 to 4 4 to 3 3 to 10 is another path. So that way if you look at it, all the nodes are somehow they are connected to one another, so that makes one connected component. So that means all of them are part of one disjoint set. Now let's see with anything we can call an articulation point. So let me see what happens if node 1 doesn't exist. So if node 1 doesn't exist, then I don't think it's going to break into multiple parts. So therefore node 1 is not an articulation point. Coming to node 2, if node 2 is removed, then you can see that it's made up of two groups after removing node 2. So the one group is having 1 3 4 9 and 10, and the second group is having 5 6 7 and 8. So it's made up of two groups now, two connected components. So 2 is an articulation point. So let me say that 2 is an articulation point. Done. Now looking at 3, if 3 is removed, what would happen? Oh God. If 3 is removed, then we have 1 4 2 5 6 7 8 in one connected component. 9 is an independent node, 10 is an independent node. Therefore this is also an articulation point. So node 3 is also an articulation point. Okay, what about node 4? If you take out node 4, will there be any problem? So when node 4 is removed, so all other nodes are still connected as a single component. So this node 4 is not an articulation point. Okay, let me continue. Then coming to node 5, what would happen if node 5 is removed? Then yes, again we have a problem. When node 5 is removed, what will happen? So all other except 6 will be part of one component. So 1, 2, 3, 4, 7, 8, 9, 10 are one component. 6 gets separated as another component. So that's another articulation point. Okay, so 5 is an articulation point. How about next one? 6. If 6 is removed, all others are intact, so 6 is not an articulation point. If 7 is removed, I don't think others break up. So 1, 2, 3, 4, 5, 6, 8, 9, 10 are all somehow connected. Therefore, 7 is not an articulation point. Then how about 8? So if 8 is removed, then still all are connected. Hence 8 is also not an articulation point. Then 9 doesn't make any difference to others. So 9 is also not an articulation point. 10, removing 10 also doesn't affect the graph. Hence 10 also is not an articulation point. So finally we can claim the articulation points in this graph are nodes 2, 3 and 5. Yeah, this is how we can identify the articulation point using the graphical method. So we are using this graph for checking whether a given node is an articulation point or not. But that requires human intelligence to solve this problem. Machine cannot work this way, so they need a different approach. So we need to look at how these 3 nodes are identified by the machine as articulation points. So for that, what type of algorithm is required, what type of data structure is required, is the matter of discussion in the future coming sessions. So keep watching. Thank you.